We have a profound aspiration, an obsession for equality, and we have a banal disregard and utter disdain for inequality. Equality in status, rights, or opportunities is both good and necessary. But the general bias that every equality is good and every inequality is evil is unjustified. In the diverse world we live in, there are bad equations and happy inequalities also. Now the problem is, we carry our subtle bias into science and mathematics. And that is the reason equations hog the limelight and attention, while eminent inequalities live in the shadows and are often ignored. The beauty of mathematics is all pervasive. It is not limited to equations and equality, but it extends and perhaps is expressed more vividly through inequalities. The uncertainty principle is an inequality which tells us why atoms don't implode, how the sun manages to shine, and strangely that the vacuum of space is not actually empty. Statistical measures based on inequalities tell us why most samples follow a normal distribution, how the Six Sigma tools improve quality, and that the extent and outreach of social and economic objectives are not actually adequate. There is no trigonometry without triangle inequality, and calculus isn't half as good if it doesn't have inequalities. From the second law of thermodynamics to sale discount up to 70%, inequalities offer it coffers in full to all interested, from the legendary Heisenberg to a conspicuous shopaholic. The topic that we'll study today is inequalities. Now, inequalities is one of the very important topics, not just for JEE Mains and Advanced, but also for your K-12 examination. So we'll start inequalities, and the first thing that we'll study in inequalities is how to represent them. So there are three ways to represent any inequality, and the first way being using symbols. Now symbols, all of you must be aware like how to use them and what are they. So I'll just mention them briefly. So there are four symbols: less than or equal to, greater than, or greater than or equal to. So I may take an example. Say for example, there is a number x which is greater than 2 but less than 3. Or I may take another example which is like there is a variable x which is greater than or equal to 2 but less than or equal to 3. Now another way of representing the inequalities is on a number line. So what I'll do is I'll just draw a number line, and I'll mark these 2 points, 2 and 3. So I need to represent the numbers that lie between 2 and 3. So what I'll do is I'll draw a line between 2 and 3. Now for this one also, again I'll draw a number line. I'll mark these points 2 and 3 again. And then again I'll draw a line. Now in the representation, there has to be some distinction between the case 1 and the case 2. Now in case 1, 2 and 3 they are not included, and that's the reason we'll put an open circle. So if we'll put an open circle, it simply means 2 and 3 they are not included. So it has all the numbers that lie between 2 and 3, but 2 and 3 they are not included. Now in the second case, because 2 and 3 they are included, we are going to use filled circle. So that's the distinction. So if a number is not included, open circle, and if a number is included, we are going to use filled circle. Now the third notation is using sets. So we can simply write it as x belongs to the interval 2 to 3. Now because 2 and 3 they are not included, I'm going to use small brackets or simple brackets. In some books you may find it as 2 and 3. Now where a number is included, I'll simply write it as x belongs to. So from 2 to 3, and because 2 and 3 they are included, I'll use square bracket. So if a number is not included, open circle and small bracket, and if a number is included, filled circle and square bracket. Now say for example, I'll say minus 2 is less than equal to x is less than 10. So now how do I represent it on a number line? So I simply take up a number line. So this is minus 2. This is 10. So x lies between minus 2 and 10. Minus 2 included. So and 10 not included. Or I can write it as x belongs to from minus 2 to 10. Minus 2 included, square bracket, and 10 not included, small bracket. So if a number is included, filled circle, square bracket, not included, open circle and small bracket. So this is how we can represent any inequality, either using symbols or on a number line or using set notation. So these are the three ways with which we can represent any inequalities. Now, in order to study inequalities, there are certain rules that we must know before we can start solving problems. And the first rule is, if we have any inequality, say for example, A is greater than B. Now, if we add or subtract something on both sides, it won't change the sign of inequality. Say for example, A plus minus C will still be greater than or equal to B plus or minus C. So by adding and subtracting anything on both sides doesn't change the sign. So in other words, if we transpose something from left to right or from right to left, it won't change inequality sign. Now the second one being, say for example again, A is greater than B and C is a positive number. So there is a positive number C. So if I'll multiply this positive number on both sides, or if I'll divide it by this positive number, then also sign does not change. So then also sign remains the same. So it's still A is greater than B. Now AC is still greater than BC and A by C is still greater than B by C. Now the third one is, if A is greater than B and C is a negative number. Now I'll take an example for this actually. So maybe I'll say 2 is greater than 1. Now what if I multiply it with minus 2? So if I'll multiply it with minus 2, what will I get? I'll get minus 4 and minus 2. Now actually minus 2 is greater than minus 4. So when I multiply or divide with a negative number, then in that case, so this is AC and BC. So sign of the inequality reverses. So A by C is actually less than B by C. So if I'm going to add or subtract something, it doesn't change the sign. If I'm going to multiply and divide with a positive number, it doesn't change sign. But if I'll multiply or divide with a negative number, then sign of inequality changes. So I'll take a two-way inequality. Maybe I'll write it as minus 1 is less than 1 minus 2x by 3 is less than equal to 5. Now I'll need to again find the range of x. So first I'll need to remove this 3. I'll multiply 3 on the 3 expressions. Now when I multiply and divide with a positive number, sign doesn't change. So I'll multiply it by 3. So I'll write minus 3, 1 minus 2x, and this is 15. Now I'll need to get rid of this 1. So what I'll do is I'll subtract 1. Now again, adding and subtracting doesn't change sign. So if I'll subtract 1, I'll get what? Minus 4, minus 2x, and this is 14. Now I need to find x. Now in order to find x, I'll have to divide by minus 2. And when I'm dividing with a negative number, sign of inequality reverses. So I'll simply write it as minus 4 by minus 2 is greater than minus 2x by minus 2 is greater than equal to 14 by minus 2. So I'll simply write it, this is 2, this is x, and this what? Minus 7. So the value of x lies between minus 7 and 2. Or I can simply write it as x belongs to minus 7 included, and then it goes up to 2 not included. So solution to this question is x belongs to minus 7 to 2. Right? The fourth one being, suppose I have two positive numbers, maybe a and b. So both the numbers, they are greater than 0. So if a is less than b, and if I take a reciprocal 1 upon a and 1 upon b, then 1 upon a will be greater than 1 upon b. So that means sign of the expression is going to change. In the same way, if I have both the numbers which are negative, maybe I'll say a and b, they are both negative numbers, and again a is less than b. So if I take a reciprocal again, 1 upon a and 1 upon b, so again 1 upon a is greater than or 1 upon b. You get a question like, they'll say suppose there is some function fx, and function fx is given by 2, and this is 5 plus 3 sin x. Find the range of this function. Now one of the way of solving this question can be, so we'll start with sin x. Now as all of us know, sin x is a bounded function, so the value of sin x lies between minus 1 and plus 1. Now first I need 3 sin x, so I'll multiply 3 with it. So I write minus 3. So when I multiply a positive number, sign doesn't change. So this is 3 sin x and then this is 3. Now I need 3 sin x plus 5, so I'll add 5. So when I'll add 5, I'll get what? 2. This is 3 sin x plus 5, and then this is 8. Now I need to take a reciprocal of 3 sin x plus 5. Now now both the numbers are positive. So when both the numbers are positive, and if I take a reciprocal, sign of inequality reverses, right? So I'll write 1 upon 2 is greater than or equal to 1 upon 3 sin x plus 5, and this is greater than or equal to 1 by 8. Now we are almost there. Now I'll just need to multiply this 2. Again, multiplying with a positive number doesn't change sign. So I'll multiply it by 2. I'll get 1. And this is 2. And this is 3 sin x plus 5. And this is 1 by 4. So that's your fx. So I'll simply write 1 is greater than or equal to fx is greater than or equal to 1 by 4. So that means the range of this function fx. So fx belongs to, and the smaller value is 1 by 4. So from 1 by 4 to 1, and both of them they are included. Simply I'll take 1 upon 2 sin x minus 1, and I need to find the range of this function, right? So I'll start in the same way. So again, sin x is bounded. So value of sin x will lie between minus 1 and plus 1. I'll multiply it by 2. So minus 2. This is 2 sin x, and this is 2, and then minus 1. So this is minus 3. This is 2 sin x minus 1, and this is 1. Now I need to take a reciprocal of 2 sin x minus 1. Now the problem here is, one of the number is negative and the other number is positive. So even if I'll take a reciprocal, if I write 1 upon 2 sin x minus 1, and if I'll change the sign, so 1 upon 1 is 1, and this minus 1 by 3. So actually it doesn't make sense, because this 1 upon 2 sin x minus 1 cannot be greater than 1 and less than minus 1 by 3 at the same time. So this is actually wrong. Now how do we solve such question when I have a negative number on one side and a positive number on another side? So this question can be solved by taking two separate cases. Case 1, when 2 sin x minus 1 is a negative number, so it is greater than or equal to minus 3 but less than 0 negative. Now 0 negative is a negative number which is nearly 0, like minus 0.0000, and it goes on. So a very small negative number. Now if I take a reciprocal, now since both the numbers are negative, now I can take reciprocal. So minus 1 by 3 is greater than or equal to 1 upon 2 sin x minus 1, and it is greater than, now 1 upon 0 negative is actually minus infinite. Now this is obvious, right? So any number is greater than minus infinite. So I'll simply write this as, so this is your fx. So fx is less than or equal to minus 1 by 3. Now the second case is when I take 2 sin x minus 1 as a positive number. Say for example 0 positive, so again a number which is just greater than 0. So 2 sin x minus 1 and less than or equal to 1. So again, now since both the numbers are positive, so I'll take a reciprocal. So if I take a reciprocal, I'll get what? 1 upon 0 positive is infinite. Change the sign, 1 upon 2 sin x minus 1, and then greater than or equal to 1. So this is obvious. So every number is less than positive infinity. So I'll simply write this as fx is greater than or equal to 1. So the range of this function will be, your function fx is either less than minus 1 by 3, so it is from minus infinite to minus 1 by 3, and minus infinite not included and minus 1 by 3 included. You cannot include infinite or minus infinite. Union from 1 to infinite. So from 1 and then from infinite. And again 1 included and infinite not included. So range of this function is either the value of this function is less than minus 1 by 3 or greater than 1. So this is how we actually solve it. In the second lecture, we'll discuss about polynomial inequalities. Now the first question is, what is a polynomial inequality? So as the name suggests, it's a polynomial. So I can write any polynomial as a0 x to the power n, a1 x to the power n minus 1, and then it goes up to an, and with an inequality sign. I'll say, suppose the question is x square minus x is less than 2 and we need to solve this inequality. So there are certain steps in these algorithms. So the first step is make a right hand side 0. So whatever is there on the right hand side, just take it on the left hand side. So I'll get x square minus x minus 2 and this is less than 0. Now the second step is, if possible, factorize. So if you can factorize, just factorize, and if you cannot, just leave it there. So I'll get x plus 1, x minus 2 and it should be less than 0. Now the third step is find roots. So simply take these factors, put it equals to 0 and find roots. So I'll get x equals to minus 1 and I'll get x equals to 2. So I get 2 roots. Now fourth step is place roots on a number line in order. So what I'll do is I'll draw a number line and I'll place these two numbers in order. So first I'll write minus 1 and then I'll write 2. So what I've done is I have placed both the roots on a number line. So what actually they have done is they have partitioned the number line in 3 intervals. Interval 1 when x is less than minus 1, interval 2 when it lies between minus 1 and 2, and the third interval when it is actually greater than 2. Now the fifth step is decide sign of the rightmost interval. So decide sign of the rightmost interval. So now there are many conventions. The convention that I follow is I'll need to decide the sign of this rightmost interval. So the rightmost interval is from 2 to infinite. So I need to know whether I should put a plus sign or a minus sign here. Now how do we decide actually whether to put a plus sign or a minus sign? Now there are 3 ways. Now one of the method is using leading coefficient. Now in any polynomial, the coefficient of highest power of x is your leading coefficient, right? So in this inequality, the highest power is x square and the coefficient of x square is 1, which is positive. So that's the reason I'll put a plus sign there. So there will be a plus sign. So this is one way. Another method can be just go to your factors and for each factor, look at the sign of the leading coefficient. Now here leading coefficient is positive. Here also leading coefficient is positive. So plus into plus will be plus. So I'll put a plus sign there. And the third method can be just take up any number between 2 and infinite and put it in the inequality. So if I take any number, maybe I'll take up 3. So 3 belongs to the interval. So if I'll take x equals to 3 and I put it there, I'll get what? 9 minus 3 minus 2, which is what? Which is plus 4. So if it is positive, I'll put a plus sign, and if it is negative, I'll put a minus sign. And then in every interval, so put alternatively plus and minus sign. So this one is plus. So the next one will be minus, and then it'll be plus. So it'll be plus, minus, and plus. Now because we are putting alternate plus and minus signs, sometimes it is also called as wavy curve method. So from plus, minus, and plus. Now the final step is I need to write the answer. Now what does these plus and minus sign actually represent? They represent that when x is less than minus 1 or x is greater than 2, the value of this expression is positive, which is greater than 0. And when the value of x lies between minus 1 and 2, then the value of expression is negative. So I'll go back to my inequality and I'll find out whether I need a plus sign or a minus sign. So if I go back to my inequality, now my inequality says it should be less than 0. Now less than 0 is obviously negative. So what I'm looking for all the values of x for which this expression takes a negative value. So this expression takes a negative value in this interval from minus 1 to 2. So answer to this inequality will be from minus 1 to 2. And because it doesn't have an equality sign, I'll simply use open circle. So answer to this question will be x belongs to minus 1 to 2 and both not included. So we'll look into all the 5 steps in Wavy curve method and we'll try and examine why we do what we do. Solve x minus 1, x minus 2, x minus 3 greater than 0. So right hand side, it's already 0. It's already factorized. So what I'll do is, I'll take up a number line. I'll mark the points 1, 2 and 3. Rightmost it is plus. So plus, minus and minus. So I need plus greater than 0. And there is not an equality sign. So I'll use open circles. So answer to this question is x belongs to 1, 2 union 3 to infinite. So we'll look into all the 5 steps in Wavy curve method and we'll try and examine why we do what we do. So the first step is make right hand side 0. The reason we make right hand side 0 is it'll be easy for us to decide whether the expression is positive or whether the expression is negative. Now, second step, why do we factorize them? Now suppose if I take a positive number and a negative number, if I'll add them, then its sum, it can be plus or it can be minus depending on the numerical values of a and if I'll multiply a positive number and a negative number, answer will always be a negative number. The logic behind factorization is we can individually look at the sign of each expression and then finally we can multiply them or divide them to find out what will be the total sign of expression, which we cannot do in the case of addition or subtraction. Now the third step is find roots. Now why do we find roots? So what I'll do is I'll look at each of the 3 expressions. Now the first expression is x minus 1. Sign of this expression changes at 1. So when x is greater than 1, it is positive. And when x is less than 1, it is negative. And at 1, obviously the value is 0. Now in the same way, for x minus 2, the sign changes at 2. So when x is greater than 2, it is positive. And when x is less than 2, it is negative. And in the same way, I can write it for x minus 3, for which the sign changes at 3. So now because sign of the first expression changes at 1, now sign of the second expression changes at 2 and sign of the third expression changes at 3. So these are my critical points and that is the reason we try and find the roots of the expression. Now the fourth step is place roots on a number line in order. So what I'll do is I'll draw a number line. I'll place the 3 roots in order. I know that my expression contains 3 factors and for these 3 factors 1, 2 and 3 they are critical points. So that is the reason I have marked 1, 2 and 3 on a number line. Now when x is less than 1 in this region, the first expression is negative, second expression is also negative and third expression is also negative. So this is minus into minus into minus, which will be minus. Now between 1 and 2, the first expression, it takes positive value. Second expression, it takes negative value. Third expression, it takes negative value. So it is plus, minus and minus. So it is plus. Now between 2 and 3, first expression is positive. Second expression is also positive. Third expression is negative. So plus into minus is minus. And when x is greater than 3, in that case, all the 3 expressions, they are positive. So rightmost, then it will be plus. So what we have done is, if we multiply all the 3 factors, then when x is less than 1, it will take a negative value. Between 1 and 2, it will be positive. Between 2 and 3, it will be negative. And then again, when it is greater than 3, this value will be positive. Now, why do I start with sign of the rightmost? What I know is, for any polynomial expression, when x tends to infinite, then sign of the expression depends on the sign of leading coefficient. So that is the only reason I start with the rightmost and I take the sign of the rightmost as the sign of leading coefficient. Now, we'll go back to our question and then we'll have a look at what do we need. We need that the product of these three expressions, it should be greater than 0, and greater than 0 is obviously positive. So the product of three expressions is positive in this interval and it is positive in this interval. So I cannot take the values of x which will make it 0. So I cannot take 1, I cannot take 2 and I cannot take 3. So answer to my question will be x belongs to 1, 2 union 3 to infinite. So that is the logic behind wavy curve method. X cube is less than 4x. Now what's the first step? Make right hand side 0. So I'll make right hand side 0. X cube minus 4x is less than equal to 0. I can take x common, x, and then x square minus 4 is less than equal to 0. So this is x. X plus 2, x minus 2 is less than equal to 0. So now I've factorized it. So there are three roots, 0, minus 2, and x equals to plus 2. So I'll put these numbers on I'll put all the three roots on a number line. So this is minus 2, this is 0, and this is plus 2. Now the fifth step, and which is sign of the rightmost. So I need to decide the sign of this interval. So when I look at the leading coefficient, so this coefficient is positive. So this is plus, then alternative plus minus. So plus, minus, plus and minus. So now I need to know whether I need a plus sign or a minus sign. So when I look at it again, it is again less than or equal to 0. Less than 0 means negative. So when I look at this negative number, so negative, it lies in this interval and it lies in this interval. So now because there is an equality sign, so I use filled circle now. I'll simply write x belongs to, now first one is from minus infinite to minus 2. So minus 2 included, and then from 0 to 2. Now it's a union of two intervals. So I'll use this union sign. So x belongs to minus infinite to minus 2, union 0 to 2. And because there is an equality sign, I'll use filled circle and square bracket. Infinity and minus infinity, they'll always be in smaller bracket, right? So this is how we'll solve such x square minus 3x plus 2, x square minus x minus 1, 5 minus x is less than 0. So right hand side, it's already 0. So I can factorize the first expression, x minus 1, x minus 2. Now I cannot factorize the second one, x square minus x minus 1. So I'll simply write it as x square minus x minus 1. And then this is 5 minus x and this is less than 0. Now I'll try and find roots of this expression. So roots are x is 1, x equal to 2. Now what about this one? So for this one, I'll simply use minus b plus minus b square minus 4ac upon 2a, and then here will be x equal to 5. So the roots of this expression are 1, 2, 1 plus or minus under root 5 divided by 2 and then 5. So now I'll put these roots on a number line. Now what's the smallest one? Smallest value is 1 minus root 5 by 2. So this one is 1 minus under root 5 by 2 and then followed by 1. Now after 1 we'll have, now what is root 5? Root 5 is 2 point something. So 2 point something plus 1, 3 point something. 3 point something divided by 2 is approximately 1.5 something. So the next one will be 1 plus under root 5 by 2 followed by 2 and then finally it will be 5. So I've represented all the 5 roots on a number line. Now I need to find the sign of the rightmost interval. So for the sign of the rightmost interval, so what I'll do is, so what is the sign of the leading coefficient in the first expression? So it is positive, right? Sign of the leading coefficient in secondmost, it's again positive, but here the sign of the leading coefficient is negative. So this is plus, plus and minus. So plus into minus is actually minus. So I'll write this as minus. So this is minus and then I'll write alternative plus and minus sign. So this is minus, plus, minus, plus, minus and plus. So this is minus, plus, minus, plus, minus and plus. Now what do I need? I need less than 0, and less than 0 is negative. So I need to find negative. So negative lies here, it lies here, and it also lies here. And now there is not an equality sign, so I'll simply use open circle. So this is open, this is open, this is open, and that's also open. So I'll simply write The answer to this question is x belongs to 1 minus under root 5 by 2 to 1, both not included, union 1 plus under root 5 by 2 to 2 not included, and union 5 to infinity. In this lecture, we'll be discussing how to divide polynomials using synthetic division. Now we'll consider both linear factors as well as quadratic factors. Now first we'll begin with linear factors. Now suppose I need to divide ax cubed plus bx square plus cx plus d with x minus alpha. Now for a linear factor, the coefficient of x must be 1. And for x minus alpha, its root will be x equals alpha. So now what I'll do is I'll draw two lines. I'll write alpha on the left of this line, and on the right hand side I'll write the coefficients of x in order a, b, c and d. Now we'll always put 0 beneath the leading coefficient. So right below a I'll put 0 and then I'll add them up. So then it'll be a. Now I'll multiply this a with alpha and I'll put the result below b, so which is a alpha. Now I'll add them. So now I'll get a alpha plus b. Now again I'll multiply alpha with a alpha plus b and then I'll put the result there, and we'll continue to do that till we get the last term. Now say for example, suppose I have to divide x cubed minus 6x square plus 11x minus 6 with x minus 2. So coefficient of x is 1 and the root is 2. So I'll draw two lines. I'll write 2 here and then I'll write the coefficients 1, minus 6, 11 and minus 6. Now right below 1 I'll write 0. Now I'll add them. So 1 plus 0 is 1. Now I'll multiply 1 with 2 and I'll put the result there, which is 2. So now I'll add them. So minus 6 plus 2 is minus 4. Now I'll multiply 2 with minus 4. I'll get minus 8. I'll add them. I'll get 3. And now I'll multiply 3 with 2. I'll get 6. And I'll add them. I'll get this result as 0. Now this is my remainder. That's the quotient. So I can write as, so this is coefficient of x square. So this is x square. Now minus 4 is coefficient of x, minus 4x. And then this is 3 and remainder is 0. So I can express x cubed minus 6x square plus 11x minus 6 as divisor, which is x minus 2, into quotient, which is x square minus 4x plus 3. Now because remainder is 0, that means x minus 2 is a factor of x cubed minus 6x square plus 11x minus 6. Now we'll come to how to divide a polynomial with a quadratic factor. Now for this quadratic factor, again the coefficient of x square should be 1. Now for the coefficients p and q, I'll take up their conjugates, so which is minus p and minus q. So now I'll draw these lines. I'll write the coefficients of the factor, which is minus p and minus q, and on the right I'll write coefficients of the polynomial. Now the first thing that we need to do is I'll put 3 zeros. I'll put a 0 here, I'll put a 0 here, and I'll put a 0 here. So now I'll add them. I'll get a here. I'll multiply this a with minus p and I'll put the result here. So I'll get minus a into p, and I'll multiply a with minus q and I'll put the result there. So I'll put this as minus aq. So again I'll add it. So I'll get B minus AP, and here I'll get C minus AQ. Now again, I'll multiply minus P with this, and I'll put the result here, and I'll multiply minus Q with it, and I'll put the result there, and then again, I'll add them. Now this is how we do synthetic division for quadratic factors. I'll take up an example. Suppose we want to divide x to the power 4 plus 4x cube plus x minus 10 with x square plus 3x minus 5. Now, I'll take the conjugate of coefficient, so I'll write minus 3, and for this one, I'll write plus 5. I'll draw the lines. And then I'll write the coefficients. So this is minus 3 and 5, and the coefficients of x are x to the power 4, coefficient is 1, 4x cube, coefficient is 4. Now there is no x squared term, so I need to put 0 also, and then it is 1, and then minus 10. So first I'll put 3 zeros, 0, 0 and 0. Now if I'll add them, I'll get this result as 1. Now I'll multiply this one with minus 3, and I'll put the result here, so which is minus 3, and I'll multiply this one with 5, and I'll put the result there as 5. So now I'll add them. So 4 minus 3 is 1, and 0 plus 5 is 5. Now again, I'll multiply this minus 3 with 1. I'll put the result here. So which again is minus 3, and I'll multiply this 5, and I'll put the result there. So which is plus 5. So again I'll add them up. So 5 minus 3 is 2, and 1 plus 5 is 6. Now again, minus 3 into 2. So minus 3 into 2 is minus 6, so I'll put it there. And 5 into 2 is 10, so I'll put it there. So plus 6 minus 6, it's 0, and plus 10 minus 10 is 0. So the remainder of this polynomial is 0x plus 0, so remainder is 0, and the quotient is x square plus x plus 2. So I can write it as x to the power 4 plus 4x cube plus x minus 10 is equal to divisor, which is x square plus 3x minus 5 into x square plus x plus 2 and plus remainder, which is 0. So in this lecture, we'll discuss logic behind synthetic division. Now for that, I'll take up an example, which is I need to divide 3x to the power 4 minus 12x plus 5 with x plus 1. And if I use long division, then I'll get the quotient as 3x cube minus 3x square plus 3x minus 15, and I'll get the remainder as plus 20. Now we'll use synthetic division. So I'll draw the lines. Now the first question that comes to the head is, for this x plus 1, why we actually take minus 1 and not plus 1? If we go back to our long division, I can see that every time when I'm multiplying the factors, I'm changing the sign. So that is the reason I need to change the sign of this term. So for plus 1, I'll take minus 1. Now I'll write coefficient of the polynomial, which is 3, 0, 0, minus 12 and 5. Now these coefficients, they correspond to coefficient of x to the power 4, x cube, x square, x, and then constant term. Now the leading coefficient in the polynomial is 3, which is 3x to the power 4. And I'll need to eliminate this 3x to the power 4. Now in order to eliminate this 3x to the power 4, I'll need to multiply this x with 3x cube. So the first coefficient of quotient is determined by leading coefficient of this polynomial. So that is the reason we always put 0 there, and then 0 plus 3 is 3. Now we'll multiply this minus 1 with 3 and we'll put the result there. So which is minus 3, and then 0 plus minus 3 is minus 3. Now why do we do that? What actually has happened is, when we have multiplied this 3x cube with x, we have got another term, and that was 3x cube, and after changing the sign we'll get minus 3x cube. So previously coefficient of x cube was 0. Now we have another term that contains x cube and whose coefficient is minus 3. So now we have two terms having x cube and their coefficients are 0 and minus 3. So 0 plus minus 3 is minus 3. So now minus 3 is my leading coefficient, and that is the reason I'll multiply it with minus 3x square. So that's why I'll choose minus 3 as the next coefficient in quotient. Now again, I'll multiply this minus 1 with minus 3. I'll put the result there. So I'll get this as plus 3, and then 0 plus 3 is 3. So again, when we have multiplied this minus 3x square with x, we have got another term, and that was minus 3x square, and after changing sign it has become plus 3x square. So now again we have two terms containing x square and their coefficients are 0 and 3. So their coefficients are 0 and 3. Now if I'll add them up, I'll get this value as 3, and that is my leading coefficient now, which I need to eliminate. So that's my another coefficient in quotient. Now again I'll multiply this 3 with minus 1. I'll get this as minus 3, and so again I'll add them up. I'll get this as minus 15, same logic, and then finally I'll multiply this minus 1 with 15. I'll get this as 15, so which is 20. So that's your remainder, and 3x cube minus 3x square plus 3x minus 15 is your quotient. So every time we are eliminating a term with leading coefficient, and when we are doing that, another term whose degree is just one less than the leading term is getting affected, and that's the reason we follow these steps. In this lecture, we'll discuss how to use synthetic division when the leading coefficient of the factor is not 1. Take up an example. Say for example, I need to divide 2x cubed plus 7x squared plus 2x plus 9 with 2x plus 3. Now here clearly coefficient of leading factor is not 1 but 2. Now if I use long division, then I can write 2x cubed plus 7x squared plus 2x plus 9 as 2x plus 3 into x squared plus 2x minus 2 plus 15. Now we'll try and solve the problem using synthetic division. Now first I'll look at the factor. Now for this factor, what I'll do is I'll take this 2 out and I can write it as x plus 3 by 2. Now for a moment I'll keep this 2 aside. I'll use synthetic division using x plus 3 by 2. Now when the factor is x plus 3 by 2, I'll need to use minus 3 by 2. So now I'll draw the lines. So I'll write here minus 3 by 2. Here I'll write coefficient of x. Now the first one is 0. So I'll write 2. Minus 3 by 2 into 2 is minus 3. 4. Minus 3 by 2 into 4. Minus 6. Minus 4. Minus 3 by 2 into minus 4. Plus 6, which is 15. Now I have my remainder, and which is 15. And here the coefficient of quotients are 2, 4 and minus 4, which is 2x square plus 4x minus 4. But that is the quotient when the polynomial is divided by x plus 3 by 2 and not 2x plus 3. So what I need to do is I'll take this 2 and I'll divide it. So if I'll divide it by 2, I'll write it as x square plus 2x minus 2, which is the quotient of my division. So now we have quotient, and now we have remainder. So now we can write this as divisor into quotient and plus remainder. So this is how we do synthetic division for factors having non-unity leading coefficient. Now in order to solve any cubic polynomial, what we need to do is we need to find at least one root, and we can find that one root by trial and error method. So what we'll do is we'll actually start putting the values of x in the expression, and we'll hope that at one value we'll get the value as 0. So we'll start with 0. If I'll put 0, I'll get what? -6, which doesn't satisfy the equation. I'll take x as 1. So if I'll take x as 1, I'll get what? 1 -6 plus 11 and then -6. So 12 minus 12. So this is 0. So you'll need to find at least one root of this cubic polynomial, and you'll find that root by using trial and error or hit and try method. Now we generally start with 0 plus -1 plus -2 plus -3, and this is the way with which we can solve a cubic equation. So there's no general method to solve any cubic polynomial equation. Now once I have this value, x is equal to 1, now I need to find other two roots. Now we can find other two roots by using either long division. So either I can use long division, and which is like I can divide this expression. So root is x equal to 1, so the factor is x minus 1. So I'll divide it by x minus 1. X cube minus 6x square plus 11x minus 6. So this is what? X square. So x cube minus x square minus plus minus 5x square plus 11x minus 6 minus 5x minus 5x square plus 5x. So this is plus and minus. So 6x minus 6 and then plus 6. So this is 6x minus 6. So I can actually write this as x minus 1 x square minus 5x plus 6 should be greater than or equal to 0. Or I can write x minus 1 and this is x minus 2 x minus 3 greater than or equal to 0. So either we can find it using long division or we can find the roots using synthetic division. So for synthetic division, I'll write coefficients of x. So I'll write 1, minus 6, 11 and then minus 6, and then here it is what? Here it is 1. So first I'll write 0, right? So now 1 plus 0 is 1. Now 1 into 1 is 1. So I'll multiply them and I'll write it here. Minus 6 plus 1 is minus 5. Now minus 5 into 1. So this is minus 5 and this is 11 minus 5 is 6. Now 6 into 1 is 6. And here I should always get 0. So I can simply write this. So the factors are x minus 1 and then I can write it as x square minus 5x and then plus 6 and then it should be greater than or equal to 0. So again it's the same expression. So either I can solve it using long division or I can solve it using synthetic division. Now once I have roots, so I'll place these roots on a number line. So this is 1 and then 2 and then 3. Now what's the sign of the rightmost? Coefficient is positive, so plus, minus, plus and minus. Now I need what? I need greater than 0. So if I need greater than 0, I need a plus value, right? So this is the plus value. So because there is an equality sign, I use filled circle. So I can simply write it as x belongs to included 1 to included 2 union included 3 to infinite. So answer to this question is from 1 to 2 union 3 to infinite. So this is how we solve any cubic polynomial or any higher degree polynomial.
Now there are some very important questions which may have conditions like ax square plus bx plus c, and they'll say ax square plus bx plus c is greater than 0 for all x belongs to R. Now what I'm given is a quadratic expression and it says this quadratic expression is positive for all x belongs to R. So in this case we are not supposed to solve the inequality, but we are supposed to find the condition with which we can say this quadratic expression is always positive. So we have studied previously that a quadratic expression is always positive when its leading coefficient is positive and d is less than 0. So any quadratic expression with imaginary roots and a positive leading coefficient will always be positive. Now, second case can be ax square plus bx plus c. It is greater than or equal to 0 for all x belongs to R. Now we have included an equality also. So for this, the condition will be, again, a should be greater than 0 and d should be less than or equal to 0. Now third case can be a quadratic expression ax square plus bx plus c is less than 0 for all x belongs to R. So quadratic expression is always negative when a is less than 0 and d is less than 0. And the fourth one is a quadratic expression ax square plus bx plus c is less than or equal to 0 for all x belongs to R. So here condition will be a is less than 0 and d is less than or equal to 0. So this we have done previously also. If a quadratic expression has imaginary roots, then it will either be always positive or it will be always negative depending on the sign of leading coefficient. If leading coefficient is positive, then it is always positive, and if leading coefficient is negative, then it is always negative. So there have been many questions on this concept. So I'll take up an example. If the inequality m minus 2 x square plus 8x plus m plus 4 is greater than 0 is satisfied for all x belongs to R, then find the least integral value of m. Find the least integral value of m. Now what I see here is, I see a quadratic expression and it says this quadratic expression is positive for all real numbers. So a quadratic expression is always positive when a is greater than 0 and when d is less than 0. So I'll need to solve these two conditions. So condition is m minus 2 should be greater than 0, which will give me value of m should be greater than 2 and d less than 0. So when I'll solve d less than 0, I'll get what? I'll get 64 minus 4 m minus 2 m plus 4 should be less than 0. So I'll divide by 4. 16 minus m square plus 2m minus 8 is less than 0. So I'll take it on the right hand side. I'll get what? I'll get m square plus 2m minus 24 and it should be greater than 0. So if I'll factorize it, I'll get what? I'll get m plus 6 m minus 4 should be greater than 0. So this is what? Minus 6 and 4 plus minus and plus. So either the value of m is less than minus 6 or m is greater than plus 4. So m is less than minus 6 and m is greater than plus 4. Now, because it's an end condition, I'll need to take intersection of these two conditions. So what I'll do is, I'll take a number line and I'll plot both the solutions. So the first solution says m is greater than 2. Now the second one says either m is less than minus 6 or m is greater than 4. So the interval where both the conditions exist simultaneously is this value. So that means the condition I'll get is m belongs to 4 to infinite. So the least integral value of m for which this is true is 5. Okay, I'll take another question, and the question is, if lambda square plus lambda minus 2 x square plus lambda plus 2x is less than 1 for all x belongs to R, then find the interval in which lambda belongs. Lambda square plus lambda minus 2 x square plus lambda plus 2x minus 1 is less than 0 for all x belongs to R. So this again is a quadratic expression is in x, and this quadratic expression is always negative. So it is always negative for all x belongs to R. So now, when is a quadratic expression always negative? A quadratic expression is always negative when a is less than 0 and D is less than 0. So when I say A is less than 0, lambda square plus lambda minus 2 should be less than 0. So I'll get what? I'll get lambda plus 2, lambda minus 1 less than 0. So the condition will be, so this is minus 2 and 1. So plus, minus and plus. So I'll need minus. So value of lambda should lie between minus 2 and 1. So now when I write D less than 0, so I'll get lambda plus 2 whole square and then minus plus 4. Lambda square plus lambda minus 2 should be less than 0. So I'll get 5 lambda square plus 8 lambda minus 4 less than 0. So 5 lambda square plus 10 lambda minus 2 lambda minus 4 is less than equal to 0. So I'll get what? I'll get 5 lambda minus 2. Lambda plus 2 is less than 0. So the condition I'll get is, so the roots are minus 2 and 2 by 5. So this is plus, minus and plus. So I need what? I need minus. So from here the condition I'll get is the value of x should lie between minus 2 and 2 by 5. Now because there's an end here, I'll need to take the intersection of these two conditions. So I'll take up a number line and I'll represent both the solutions. So this is between minus 2 and 1. So minus 2 and 1 both not included. And the second one is between minus 2 and 2 by 5. So answer to this question is lambda belongs to minus 2 to 2 by 5 and both not included.
In the last class, we have discussed polynomial inequalities. Now, in this class, we'll discuss 3 very important rules that we need to use in any inequality. So let us take a question. So the question is x to the power 4 plus x square plus 2 e to the power x plus 2 mod x plus 3 sin x minus 2 into x minus 1, and this should be less than 0. Now, when I look at the first expression, x to the power 4 plus x square plus 2. So now this expression will always be positive for all x belongs to R. Now exponential function, any exponential function, it's always positive, and with plus 2, so this expression will again be always positive. Mod of x plus 3, again it will be always positive. Now what about sin x minus 2? What is the minimum value of sin x? Minimum value of sin x is minus 1. So that means the minimum value of this expression is minus 3. And what is the maximum value of sin x? Maximum value of sin x is 1. So 1 minus 2 is actually minus 1. So the range of this expression is from minus 3 to minus 1. So that makes this expression always negative. So this expression is negative, always negative for all x belongs to R. Now x minus 1, it will change its sign at 1. So when we have such situation where in our inequality there are certain expressions that doesn't change sign, we'll go to rule number 1. Now what's rule number 1? Rule number 1 simply says, if in your inequality there are certain expressions that doesn't change sign, we can simply remove the expressions from the inequality keeping the sign. So that simply means in my inequality, I can remove the first expression, second, third, and fourth, keeping the sign. Keeping the sign means I'll keep this plus sign, and then this minus sign. So plus into plus into plus into minus is effectively minus. So I'll simply write minus x minus 1 less than 0. So now I'll multiply with minus 1. So if I'll multiply with the negative number, sign reverses. X minus 1 greater than 0. So which is x is greater than 1. X minus 1 to the power 4. So either it can take a positive value or it can be 0. So sign of this expression doesn't change. So rule number 1 says I can remove it from the inequality. Now also for this x minus 8 to the power 10. So again it's an even power. I'll remove this expression from the inequality. So odd numbers or odd power actually doesn't make any difference. So what I'll do is I'll remove the power. So I'll write this question simply as x minus 2, x minus 5, and this is less than 0. So now again I can solve it. So roots are 2 and 5. So this is plus, minus, and plus. So I need minus, not included. So x belongs to 2 to 5. Now another thing which is very important in solving these inequalities, and especially in calculus, it will be, so you'll get a quadratic expression. So this is ax square plus bx plus c. So generally when we get a quadratic expression, what we do is we try and factorize it. So if we can factorize it, well and good. If we are unable to factorize it, we'll use minus b plus minus root d upon 2a. So there may be a case when for this expression d is less than 0. So if for a quadratic expression the value of d is less than 0 or it has imaginary roots, then its sign won't change. So now its sign will depend on its leading coefficient, and its sign will actually depend on this a. If a is negative, then it is always negative. And if a is positive, then it will always be positive for all the values of x. Now rule number 2 and 3, they are used with rule number 1. So I'll take one example. Say for example, I'll say there is an inequality expression which is x minus 1 to the power 4, x minus 2 cube, x minus 3 to the power 6, x minus 4 to the power 11, and this should be less than 0. Now rule number 1 says I can remove even power expressions. So I'll remove x minus 1 to the power 4, x minus 3 to the power 6. Now odd power, I need not bother about these parts. I can simply write it as x minus 2, x minus 4 is less than 0. So that's rule number 1. So what I'll do is I'll simply solve it. So when I'll solve it, I'll get what? So there are two roots. So this is 2 and this is 4. So sign of the rightmost. So this is plus, this is plus. So this is plus, minus and plus. I need less than 0. So I need minus. So answer should be x belongs to 2 to 4. But what will happen if I'll put 3 in the question? If I'll put 3, what I'll get? I'll get 0 is less than 0, which is obviously not true. So what rule number 2 says, if the expression or if the inequality doesn't have an equality sign, then we'll need to remove the roots of the expression which we have removed. So what we have removed? We have removed x minus 1. So the root is x equal to 1. And we'll also need to remove this one, x equal to 3 from the final solution. So our final solution is between 2 and 4. This final solution doesn't have 1. So I need not bother about 1. But this solution, it does have 3. So rule number 2 says I need to remove this 3 from this solution. So what I'll do is, so from this solution, I'll remove 3. So answer to this question will be x belongs to 2 to 4 except 3. Or I can write x belongs to, so from 2 to 3 not included union 3 to 4 not included. So rule number 2 simply is, if we have removed any expression in rule number 1 and if the inequality doesn't have an equality sign, then you may need to take out the roots of these expression from the final solution. Now what about rule number 3? Rule number 3 is again used with rule number 1. So again I'll take up an example. Say, so now again rule number 1 says remove 2 and 4. I'll simply write x minus 2. X minus 4 is less than equal to 0. So the roots are 2 and 4. Rightmost plus, minus and plus. I need minus. So x belongs to 2 to 4. So that's your rule number 1. Now rule number 3 is used when it has equality sign. So when it doesn't have an equality sign, we'll use rule number 2. When it does have an equality sign, we'll use rule number 3. Now rule number 3 says, if any inequality has an equality sign, then we may need to add the roots of the expression which we have removed in the final solution. So what we have removed? We have removed x equal to 1, x equal to 3. So now I need to add 1. So 1 is not there. So I need to add 1. And then x equal to 3. X equal to 3 is already included. So answer to this question is x belongs to 1 union 2 to 4. So answer to this question, either the value of x is 1 or x lies between 2 and 4, both inclusive. So there will be many questions where there will be expression that doesn't change sign. So in all these questions, we need to use rule number 1, and with rule number 1, we'll use either rule number 2 or rule number 3.
In this video, we'll examine what is the logic behind 3 cardinal rules of inequality. Now the first rule is, in my inequality, if there are certain expressions that doesn't change sign, I'll remove the expressions from the inequality, keeping the sign. So in my inequality, this x square plus 1, it is always positive, and sin x minus 3, it is always negative. So I'll remove it, and then I can write it as minus
x minus 1, x minus 2 less than 0. So the roots are 1 and 2. So this is minus, plus and minus. I need minus. So answer to this question will be x belongs to minus infinite to 1 union 2 to infinite. Now what's the logic behind this rule? So what I'll do is I'll take up each expression. So I'll write x square plus 1. Now x square plus 1 is positive for all x belongs to R. So it cannot take a negative value. So it will always be positive for all x belongs to R. Now sin x minus 3, minimum value of sin x is minus 1. So minus 1 minus 3 is minus 4. And maximum value of sin x is 1. 1 minus 3 is minus 2. So its value will always lie between minus 4 and minus 2. And therefore this value will always be negative. So it is negative for all x belongs to R. Now x minus 1, the expression changes sign at x equal to 1. So when x is greater than 1, it will be positive. And when x is less than 1, it will be negative. In the same way, x minus 2, it will change sign at 2. So when x is greater than 2, it is plus. And when x is less than 2, it is minus. So again, I'll take up a number line. So the critical points are 1 and 2. So I'll mark them on a number line. Now, when x is less than 1, in that case, it is positive, it is negative, it is negative, and it is negative. So plus into minus into minus into minus is minus. Now this is plus into minus, plus into minus. So there'll be plus, and then it'll be plus, minus, plus and plus, which is minus. So I'll get minus, plus and minus. Now what's happening here is if I'll multiply first two expressions, then plus into minus will always be minus. Minus into minus is minus. Minus into plus is plus. And minus into plus is minus. So effectively these two expressions, they do not contribute to the sign change other than this minus sign. So that is the reason we remove the roots of the expression which doesn't change sign in rule number 1. Now we'll come to rule number 2. So the question is x minus 1 square into x minus 2 into x minus 3 to the power 4 into x minus 4 is less than 0. So rule number 1 says these positive expressions, they won't change sign. I'll remove them. So the two roots are 2 and 4. So rightmost is plus. So it is plus, minus and plus. I'll need minus. So this is x belongs to from 2 to 4. Now rule number 2 says because it doesn't have an equality sign, then we need to remove real roots of the expressions which we have removed in rule number 1 from the solution if they are included in the solution. So the two expressions which we have removed in rule number 1 have the critical points x equal to 1 and x equal to 3. Now 1, it's not included in the solution. 3 lies inside the interval. So that means I need to remove 3. So answer to this question will be x belongs to from 2 to 4 except 3. Now what's the logic behind it? So again, I'll write sign change for each expression. So first I'll take x minus 1 square. Now critical point for x minus 1 square is 1. So at 1 the value is 0. But for all the values of x, it'll be positive. Now the sign of x minus 2 changes at 2. So after 2 will be plus and before 2 will be minus. Now x minus 3 to the power 4, again it has an even power. So critical point is 3, but it is an even power, so sign doesn't change. It will always be positive, but then it will take the value 0 at 3. Now finally I'll write x minus 4.
So critical point is 4. So plus, 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 and then minus. Now again, I'll take a number line. So the critical points are 1, 2, 3, and 4. 1, 2, 3, and 4. Now when x is less than 1, it is plus into minus, so it is plus. Between 1 and 2, it is plus, minus, and minus, so which is again plus. Now between 2 and 3, it is plus, and minus, so it is minus. And between 3 and 4, it is plus, and minus, it is minus. And then finally it will be plus, and plus, so again it will be plus. Now what do I need? I need less than 0. Now less than 0 is negative. So negative lies in this interval. Now as we can see there, its value is negative when x lies between 2 and 3 and when it lies between 3 and 4. Now at x equal to 3, the value is actually 0. So that means my answer will not contain 3. So I need to remove 3 from the solution. So that is the logic behind rule number 2. Now for rule number 3, question is x minus 1 square, x minus 2, x minus 3 to the power 4, x minus 4 is less than or equal to 0. So now there is an equality sign here. Now rule number 1 says I can remove 1 and 3. So the roots are 2 and 4. So it is plus, minus, and plus. Now rule number 3 says if your inequality has an equality sign also, then we need to remove real roots of the expressions which we have removed in rule number 1. So that is x equals to 1 and x equal to 3 if they are not included in the solution. So 3, it's already there, but we do not have 1. So I need to add 1 to it. So answer to this question will be x is either 1 or it lies between 2 and 4. Now we'll examine the steps in rule number 3. So I'll take up first expression, which is x minus 1 square. Now because it has an even power, it will always be positive, except at 1 it will be 0. Now x minus 2, it changes sign at 2. X minus 3 to the power 4, again even power, so there is no sign change. But at 3 it will be 0, and then it is x minus 4. Critical point is 4, so there is a sign change at 4. So again I'll take up a number line. I'll mark all the critical points. So this is 1, 2, 3, and 4. When x is less than 1, it is plus, and minus, which is plus. Between 1 and 2, it is plus, and minus, which again is plus. Between 2 and 3, it is plus, and minus, which is minus. Between 3 and 4, it is plus, and minus, which is again minus. And then when x is greater than 4, it is plus. Now what do we need? We need less than or equal to 0. Now less than 0, it lies between 2 and 4. And equal to 0, it is 0 at 1, 2, 3, and 4. So that is, answer to this question will be x is either 1 or x lies between 2 and 4. And that is the logic behind rule number 3. Now here I can factorize this one, x into x minus 1. But for this, what is the value of d? 1 minus 12 is minus 11. So now coefficient of x square is what? Positive. So it is always positive. So I'll remove the expression. Rule number 1 says remove the expression. So I'll remove the expression from the inequality, keeping this sign. So simply it will be 0 and 1.
Coefficient of x square is positive, so plus, minus and plus. So answer to this question is value of x will lie between 0 and 1. So the value of x will lie between 0 and 1. So this is how we'll use this fundamental. So rule number 1 again is, if there is any expression in the inequality that doesn't change sign, we'll remove the expression from the inequality keeping the sign greater than 0, right? So now rule number 1 says I can remove 2, 4 and 6. So I can simply write it as x minus 2, x minus 4 greater than 0. So the roots are what? Roots are again 2 and 4. So rightmost, so plus and plus. So this is plus, minus and plus. So I need to what? Greater than 0 plus. So this is what? This is less than 2 or greater than 4. But then now, because it doesn't have an equality sign, I look at rule number 2. So what is the root of the expression that we removed? So the roots are 1, 3 and 5. So 1 it's included, right? So I'll need to remove 1. So I'll remove 1. 3 it's not there, right? So I cannot remove anything which is not there. And then I'll need to remove 5. So answer is x belongs to, so from minus infinite to 2, union 4 to infinite, except these two values, except 1 and 5. Or I can say x belongs to from minus infinite to 1, union from 1 to 2, union 4 to 5, union from 5 to infinite. So that's your rule number 2.